All right, guys, lesson 2 for conics. Talking about ellipses and circles today. We're going to talk about graphing them and how to write the equations of them. So first of all, let's talk about what a circle is. A circle is the collection of all the points that are equidistant from a center point. So if I were to put a dot here and ask you guys to find all the points that are, let's say, I don't know, like maybe 6 inches away from it. After you've found them all, you would find that all the points that are 6 inches away from the center make a circle. So that's what a circle is. It's basically all the points that are equidistant from some central point. The equation of a circle looks like this. Okay, so H and K represent the center. R represents the radius. X and Y represent any of the points that are on the outside of the circle there. Okay, so that's what the equation of a circle looks like. So let's go ahead and take a look at our first example here. I want to graph this circle. The first thing I'm going to do is I'm going to identify my center. The center is the number that's with the x, but opposite sign, and the number that's with the y, but opposite sign. So there's my center. The radius will be the square root of whatever number's over here. So the square root of 9 is 3. Now with those two pieces of information, we should be able to sketch a circle. So I'll show you how. I'm going to find my center point first, 2, -3. Next, I'm going to use my radius to find 4 points. I'm going to go up 3 from the center, down 3 from the center, left 3 from the center, and right 3 from the center. So let's do that. So from the center, if I go to the right 3, that puts a dot here. If I go to the left 3, that puts a dot here. If I go up 3, that puts one right on the x-axis. And if I go down 3, that puts one down here. At that point, I pretty much have enough information to kind of sketch a rough estimate of my circle. And there you have it. So that is the graph of this equation here. So step 1, find your center. Step 2, you find your radius. Step 3, graph it. All right, throwing it at you guys. Go ahead and pause the video here. When you unpause it, you'll see the solution. All right, guys, so there's a solution. One little tricky part is you'll notice there's no number there with the x, which means that that h part is 0. The rest of it's pretty straightforward, so I'll let you guys study that, and we'll go ahead and move on to our next part of today. So now we're going to move on to the ellipse. The ellipse is basically like a stretched out circle. Now, the way that an ellipse is formed is with 2 dots, which are actually like on a parabola. They're called the foci. And basically, any point along the blue line, like if we chose this point right here, if you were to take the distance from that point to one focus and add to the distance to the point of the other focus, that distance will be, let's say, I don't know, let's just say it's like 18. I'm just making up a number. Well, anywhere else in the circle, like let's say you picked this point right up here, the distance of that point to each focus will also be 18. So no matter where you pick, those distances will always add up to 18. So what an ellipse is, it's the set of all points whose distances from the points on this ellipse, or sorry, the points of the foci are always the same amount. That sum will always be the same distance. Ellipses are pretty useful when it comes to modeling planet orbits and whatnot. So let's go ahead and look at the equations of an ellipse. Sometimes they could be stretched horizontally and sometimes they could be stretched vertically. And it all depends on the equations up here. So let's take a look at these equations. Now, once again, H and K represent the center, so we need to add that to our notes right now. So in other words, this would be, the coordinates of this point would be H and K, and the coordinates of this point would also be H and K for this one over here, because they both have H and K. All right? Now, the number underneath of the x if you take the square root of that, that's going to tell you the square root of this number that's underneath the x, that's going to tell you, I'll call it the x radius. You guys know what a radius of a circle is, right? Well, technically an ellipse has a constantly changing radius. It's different in different places. Like here it's really, really long, and here it's really short, and here it's not quite as long as the longest, but not quite as short as the shortest, etc. So it doesn't have a single radius. So I'm just going to call it the x radius, although that's not official math language, but I think it's helpful. And the reason for that is because it's your horizontal distance from the center to the outside of the ellipse. So we'll call it the x radius. Now if you take this number and take the square root of it, that will tell you your y radius. And once again, that's not official math language, but that's what I like to call it. So that's your y radius is the b value. Same thing applies over here. In this case, the square root of that would be a, so that's my y radius, and that would go here. And here my x radius would be b, because that's the square root of this one. So the number that's underneath of the x, if you take the square root of it, it gives you your x radius. The number that's underneath the y, if you take the square root of it, that tells you your y radius, okay? And at that point, we really have enough to go ahead and get a graph going. So here is an equation of an ellipse, and our goal is to graph it. So step one is to identify your center. So the center, the x1 is the one that's with the x but opposite sign, and the y coordinate of the center is the number that's with the y but opposite sign. But there's no number with my y there, so that means it's 0. Now I want to find my x radius. That is the number that's underneath the square root, but we're going to underneath the x, it's underneath the x, and we want to take the square root of that number, which is 5. So my x radius is going to be 5, and then I want to find my y radius, and that's the 4, so we're going to take the square root of the 4, which gives me 2. At that point, we have enough to go ahead and sketch an ellipse. So I'm going to plot my center, which is at 1, 0. And now I'm going to do my radiuses. So my x radius is 5. So starting from my center, I'm going to go 5 to the right, 5 to the left. Now I'm going to do my y radius. I'm going to go up 2 and down 2. So it's a lot like doing a circle. It's just that we have 2 different radiuses that we're going to look at. And we go ahead and connect the dots like so. And there's my little ellipse. Okay? So pretty similar to graphing a circle. Here's one for you guys. Go ahead and pause the video, give it a try, and when you unpause it, you'll see the solution. All right, guys, and so there's a solution. So go ahead and pause the video here and study it if you need to. And we'll go ahead and move on to the next one. Let's go ahead and move along. We're going to be given some equations like this, and what we want to do is we want to change them into either, let me see if I can bring it back here, either one of these equations or the equation of a circle. So in other words, we got to change the way it looks, and the way we're going to do that is pretty much the same way we did parabolas yesterday. We're going to group our x's and group our y's, complete the square, and get it to look like what we need it to look like. So step one is to group your x's and y's in parentheses. We're also going to move the constant to the other side. So I'll show you what I mean by that. So I'm going to put my x's together, this guy and this guy. I'm going to put my y's together, this guy and this guy. And then this guy over here, the constant, I'm going to move it to the other side by subtracting it. So if I were to do that, it would look like this. we're going to put x squared with 12x. We're also going to put the y's together. So that would be 16y squared plus 128y. And then we're going to move the constant to the other side, so now it'll be negative. Okay, so all I've done is I've rearranged things a little bit, because whenever we're looking at equations of circles and ellipses, the x's are paired together and the y's are paired together. But we need to complete the square, because I don't want it to look like this. I want it to look like this. And that's a completing the square kind of a situation there. So let's go ahead and do our completing the square. For the x, it's going to be pretty simple. So I'm going to leave that one alone for now. Let's go on to step 2. Step 2 is to factor out coefficients. So factor leading coefficients. Now for my x's, all I have here is a 1, so I'll write the step like I'm doing it, but it really doesn't matter to take out a 1. You don't have to do that. But just so you can see it on the steps, we'll do it. Now the blue one, though, it does matter. We need to take out that 16 out of the front there. So I'm going to take a 16 out. And I don't know how many times 16 goes into 128. Let me get my calculator. Okay, so that would be 8 times. So that's step 2. So factor out the leading coefficient from each pair. So I took a 1 out of the red one, and I took a 16 out of the blue one. All right, let's continue. The next step is going to be to complete the square. So that means we're going to be adding a number in each one of these sets of parentheses. All right, so let's see if we can figure out what that number is. If I take half of 12, I get 6, and if I square that, I get 36. If I take half of 8, I get 4, and if I square that, I get 16. All right, let's move on to the next step. Make sure you guys are writing these steps down as you go. There's a lot of steps on these, so you're going to want the words along with the actual problem so that you can follow them for future problems. Now, the next step is to fix the balance. Okay, you're not allowed just to add numbers on one side of the equal sign. If you add it on one side, you have to add on the other. So we're going to do 1 times 36 and add it to the other side. Matter of fact, I think I'll just show my work up here. Should have been a plus down here, guys. Okay, so we're going to do 1 times 36, and we're going to add that over here. And we're going to do 16 times 16. We're going to add that over here. I think 16 times 16 is 256, if I'm not mistaken. So that keeps it balanced and fixed. That way, whatever I've added to the left side has also been added to the right side. Okay, the next step is going to be to factor and add. So factor and add. So here, if I factor this, it's going to end up looking like this. All that's going to, we have to figure out is that number there, and once again, it'll always be half of this, so that's plus 6. Same thing with this guy here. It's going to look like this. Half the middle number is 4. And then, so that's factoring, but we also want to add all these numbers over here on this side. And that gives me 144. All right. The last step that we're going to do is we're going to divide and reduce. So what are we going to divide? Well, we're going to divide both sides by 144. So I'm going to divide 144 here. I'm going to divide 144 here. I'm going to divide 144 here. Now, for this first one here, it doesn't need to be reduced. That's as good as it gets. For the next one, I'm not sure if 16 goes into 144 evenly. Let me see. It does. But basically, if you want to reduce these guys, just take this number here, divide it over, and put it over this one here on the bottom. It's kind of like a little shortcut for figuring it out. So 144 is divisible by 16. It goes in there 9 times. Now, if it wasn't divisible, then you would just reduce that. Okay, but for now, we'll just leave it as 9. And then on this side, we get a 1. And that's it. We have changed it into the transformational form for an ellipse. So that's an ellipse. It has a center at -6, -4. The x radius would be 12, and the y radius would be 3, and we could graph it. We wouldn't know that at all by looking up here, but we can see down here what it is. Okay, and so that's the process. It's a 6-step process. So let's have you guys give one of these a shot here. Go ahead and pause the video. Give this one a try. When you unpause it, I'll have all the solution up for you. All right. Now, I didn't do the last step, but I'll explain why in a second. But here is the process. So if you want to pause and check your first 5 steps, go ahead. We really didn't need to do step 2 because there was really no leading coefficient, but just to kind of represent step 2, I put a 1 in the front. Other than that, I feel like all this is pretty self-explanatory. Now, let's talk about why did I stop on number 5 and 6? Well, because this is the equation of a circle. Anytime, I mean, if you were to divide the 5, you could do that. But as you guys can see, what that's going to result in is the x and the y are both going to have the same radius. So if you have a circle where the x radius and y radius are the same, you have a circle. You don't have an ellipse. And with ellipses, we typically don't divide. I'm sorry, with circles, we typically don't divide. We just leave the number over here, and that way we just know that's our radius. But if you wrote it the other way, it's not technically wrong. But just so you know, anytime if these coefficients are the same, then that's kind of as good as it gets. I mean, you're not going to be able to go much further than that. So that would be the equation of your circle there. All right, guys, so that being said, I think we'll go ahead and call it quits there. So we'll see you guys in class to put this stuff to practice. See you then.